So far we've done the ones that are very straightforward application of the product rule, and the three examples that we've looked at so far. Uh, in fact, each of them in some way involved a power of x. Uh, but our next example shows us a situation that's a little bit more complicated. A little bit more complicated. Hold on, I gotta get it to move the right way. Here, oh, come on. Okay, so in this one that we're looking at here now, we have the e to the 2x cosine x. So in this case, we have neither one of them is something that has a derivative that will eventually disappear. So we pick one to be our u, we pick one to be our du. It actually turns out in this problem with e to the 2x cosine, or if you had an e to the x and a sine x, the same kind of thing, it actually doesn't matter which one you let be u or du, or u or dv. It actually doesn't make a difference. It will eventually work. But here's what I want you to see here. Let's just take a look and let's just try this. Integrating or differentiating e to the 2x is slightly easier than integrating it. So I'm going to go with that one. And it's pretty easy to integrate cosine. We know how to do that. So I'm going to go with them that way. And then differentiate du. Derivative of e, remember, would be itself, and then times the x1, derivative of the x1. So that would actually be 2e to the 2x dx. And then we integrate v. And integral of cosine is just simply sine, right? And hang on just 1 second. It's just some issue with my device. It wasn't letting me generate a second page, which is kind of weird. Okay, so anyway, we let one of them be u, one of them be dv. Again, if you did it the other way, it actually isn't going to matter. Okay, it will actually still work out. Okay, so then we do our process, right? This would be uv, so e to the 2x sine x minus the integral of v du. So 2, right, because it's 2, e to the 2x sine x dx. And so once again, we're faced with an integral we can't do. So we once again apply our integration by parts. So we apply our integration by parts. So I'm going to let u once again be the e part, e to the 2x. I'm going to let my dv be my sine x dx. Okay, differentiate u. That's still just like last time. Going to be 2 e to the 2x dx. Integrate v. Remember integral sine. Sine integrated, sin. Sine I integrated, n. Negative. Sine integrated is negative. Negative cosine x. Okay. So just working with this piece here, I'm going to have minus 2, and then using my integration parts, uv, so that'll be a minus e to the 2x cosine x minus the integral of v du. Okay, so I'm going to have a negative cosine here, so That'll be a negative 2 integral of e to the 2x cosine x dx. And now we see a bit of a problem. And at first, we're utterly dejected by it because we're like, this is so stupid. This is so stupid because I started with an integral of e to the 2x cosine x. I did my integration by parts once. I did it a second time, and darn it, I'm back to the same stupid thing again. What do I do now? Why did this do this? And what can I do now? Actually, this is not a bad thing. This is actually not a bad thing here. Although at first it seems like it is. So let me rewrite where we're at now. Do a little bit of simplifying here. So my original problem was integral of e to the 2x cosine x dx equals, and then I had e to the 2x sine x, e to the 2x sine x. Okay, then I have a minus 2 times minus e to the 2x cosine x. I'm going to have two of those, right? So 2 e to the x, e to the 2x, sorry, cosine x. And then I'm going to have a minus 2 times a minus minus 2. That will be minus 4 times the integral e to the 2x cosine x dx. And here's where you want to see the light. Originally, we had this thing, e to the 2x cosine dx. Now we have over here minus 4 times that. So guess what, though? This is an equation. This side is equal to this side. So what we can do is take this piece right here and add it onto the other side. And that's exactly what we're going to do. Okay, that will then give me 5 times the integral, because you have one of them plus 4 of them. So 5 times the integral e to the 2x cosine x dx is equal to all this stuff, e to the 2x sine x plus 2 e to the 2x cosine x. And then simply we just have to divide by 5, and don't forget to include the constant of integration. Okay. So don't forget then to also include the constant of integration, because these integrals had constants, I just hadn't been bothering to write them down. So finally we get that our original thing, e to the 2x cosine x, is equal to 1/5 e to the 2x sine x plus 2/5 e to the 2x cosine x, and then don't forget, of course, our plus our constant of integration. Okay, and so this is a case where we had to do it twice, and at first it seemed like that led us into a hopeless place, but we're able to bring that over. We're able to bring that over and actually then solve for the integral by dividing by 5. And now we have the antiderivative of e to the 2x cosine x. If you were to take this thing, go through the process of differentiating, all right, using the product rule here and the product rule here, as you go through, you would eventually get e to the 2x cosine x is all that's going to be left over. Okay, so definitely a more advanced example here. But that's something you want to be on the lookout for when you have integrals involving e and cosine and e and sine. This type of thing is something you want to keep a lookout for.